Thank you. I'm Joachim Lindborg. I'm working here in Stockholm on a little company called Sustainable Innovation, and we do energy efficiency projects to create more sustainable environments. And it's a vast majority between quite different companies. So we try to work together with Toyota and Riksbyggen or condominium owners, get the utilities to talk to end users. So we try to be in the middle of all this, which get us a bit cross-sector structure. So we get the academia to talk to entrepreneurs to create projects towards big companies. And doing energy efficiency, you always end up in a problem of measuring. You need to measure to know that you've done the energy efficiency you want to. And working with big companies, you tend to get stuck in very big systems. So in doing all this device explosion that's now happening, we get tons of interesting devices we've seen here today. They all connect to something often, and they need to produce services, otherwise you wouldn't get any revenue. So you need to connect them to the nice clouds. And you get loads of different clouds. Preferably it's an open world. You get an invite, you can use the cloud. It's a nice API, you can push data to it. Hopefully you can retrieve it as well. But if there's a service somewhere in the game, and perhaps even a business model, it tends to be a bit more complicated. The device connects to internet over your own network, of course, transport the data totally closed to a cloud service to provide you the nice service, which you dare to get. Look for the Philips Hue, the lamps we just saw. What they do is that they get an IP address at your home, transport everything up to the cloud, and nick it into some nice API. Philips Hue is a bit different, though, from the Wemo. They actually have an API on the gateway locally, so you could talk to them in their nice API. And these APIs tend to be a bit different between companies. They could be somewhat RESTful. They could use hash keys to authenticate. They could use OAuth. So if you're a company doing larger scale energy efficiency service for perhaps a utility, you need to integrate every heat pump's different open APIs. And you tend to get to create your own devices, of course, because that's the easiest way. Therefore, energy efficiency services doesn't happen today. The only ones to do it is the one that provide their own hardware. Again. So if you are in a house having nice services, you have scales measuring your body temperature or body weight, it's very hard to get the refrigerator to lock based on the weight, because it's so far away on those clouds. So you end up with those business silos yet again. And we wait still for that interoperable, nice transport layer at home, which now are, how many do we have? Zigbee, Z-Wave, KNX, on Ocean, Z-Wave, any others? Your own created things. And towards the clouds, you could use quite a lot of things to connect it, throw data up, get data back. You need to transport over networks. And then we have the final goal of the IPv6 world where everything is nice, which just will happen in any decade now. We still wait for the interoperable connected temperature to temperature in any IP network. So you end up then in your home, sitting in the middle, having an alarm system from some company, having a heat pump from another company, having perhaps a refrigerator from a third company. And if you thought they would be able to integrate their APIs, it would not happen. So how to get everybody to do the same thing. How to transport that measurement data between all these domains, trapping all these business models. Well, you actually use a network that is very interoperable. How many have chat? How many use Facebook chat, for example? Google Talk? Few? You can chat from a Gmail account to any other XMPP-enabled chat client on any other domain. Quite a good thing. And the server at Google Talk are federating the other domains. So any domain can talk to any domain if they install each other's certificates. So you can at any time turn any domain off if you're a service provider. So if you lever that chat knowledge to things, you tend to be friend to somebody. You don't talk to them otherwise. So only if you're a friend, you allow them to talk to you and you to talk to them. And they can be on any domain. So you can join a group, have a group discussion, a multi-user chat room, for example. And in a multi-user chat room, you can be anonymous. You would just provide a nickname. So say that we have a smart city that needs power values from users at home. They could join the smart city power room and say how much power they need right now. Of course, we would need to know a bit about how the grid is sort of geographically. It wouldn't be nice to have the Luleå power down in Uppsala, because you just joined that room. But it's an interesting thing of being anonymous and providing data to other people. A bump in the road. I can send the GPS position with a bump, never revealing it's myself doing it. But if 10 people do that, it probably is a bump in the road at the same place. Then we could fix it. So energy efficiency-wise, we're running a project based on Vinnova money, and also the companies, of course, where we let the alarm systems, Securitas and Verisure, talk to heat pumps from Enertech and Fissman. So the temperature in your smoke detectors are chatting with the heat pump. They get friends. They're in different domains, but they can talk to the other domain. So there's nobody in the middle. Because as soon as this business model is relying on an integrator somewhere, that integrator is dead, really seriously evil, because he takes all the data. So if you're a utility, you can't use an integrator, because they will have all the data that it's yours. And if you're 10 companies doing together the same integrator, everybody will look at each other and say, well, be careful now. In the XMPP and the chat world, you always get this peer-to-peer between the server domains. So you can start with being together with your other company that you take a serious agreement with, and then add on others. So regardless of who's starting, you can always federate the next one. How many are familiar with the XMPP chatting network, how it works? No, not really. How many knows how SMTP and the email network work like? Good. So in SMTP email, you go to an SMTP server, you throw your email in, the SMTP server looks at the domain, throws it to the other domain, and that one will bring it to your client. Problem is that when you go to an SMTP server, you can send them email to any domain. That's the goal of the Gmail or the mail. It should be going everywhere. So if you pour in spam in one end, it would pop up in the other end. But in the chatting network, no server can talk to any other server unless they are federated. And no client can talk to any other client unless they are friends. So it's very hard, it's harder to get spam into this network. And it's been around since 2002. Millions of users use it. So it's very generic, it works, millions of users, and it's very lot of different implementations. You can get servers in any language. Pure C, Lua. The process is created in Lua. Erlang, whatever. Install the one you want to. And they are based on the standard of how they communicate. Client to server, server to server. Very defined in IETF. Interoperable world works very nicely. And security-wise, the XMPP network is now, during the spring, hardening the whole network. So if you are a server federating other domains, taking part in the federating domain, you will be shut off if you ever allow old certificates, low security certificates, and TLS to your clients. Do you use plain text passwords, your domain will be shut down from the other ones. And that will be from May. So every client is obliged to go to TLS session towards an XMPP server, which does get an Arduino to have a trouble connecting. But a Raspberry is no problem. So there's a level of devices that could connect to this network. So it's not aimed on getting a wall switch turning on your lamp. You shouldn't do that with this technology. Go for MQTT or direct sockets or whatever. But from your home, talking to your phone over internet, that's the way where it should be. So perhaps your gateway thing, it would connect to the XMPP network, and you would be able to befriend with your house, reading the sensors inside. And that brings us to the clients, which then also can be in any language. There are implementations in Python, C, Lua as well. So if you do that, you get the devices, you know how the standard looks like, which is open. It's done at the XMPP organization. It's only one, no differences. It makes the devices be able to bring the domains. Bridge. A temperature sensor from Verisure would look just as a temperature from China smart things. It would be an XML package saying this is the temperature in Celsius and it's the number 42. And anybody who can read XML would understand when they parse it, go through the schemas, verifying this looks right, and it would look the same thing in either end. So at the xmpp.org, we have now worked a few of those extensions. One extension to this extensible messaging presence protocol is presence. So when your clients turn green, they are sending the presence message, which is an XML standard of how that should look like. So you can create any extensions to this network. And if the clients are able to adhere to them, they would respond. So there's a knowledge of discovery. You can ask any other client, what can you do? Well, I'm a chat client. I'm a device. I'm readable. I'm not readable. So there 323 and 325 are censoring data and control. Read and write data. So what can we then do? Well, we can get presence from devices. They are getting online. They are doing friendship relations. And you would get this very nice place where a service can be more or less in anywhere. At least it needs two friends. So in the example in the session before, you have a sensor and some device, and you need some logic. You can either put the logic in one of the clients, or you can have a third place where you're running the client on your phone, or in your gateway at home, or in your big clustering Amazon machines. They just need to be clients. So you don't need a server cloud where everything is passed and then changed and then pushed out. Any client talk to any client. A client could be a statistical engine asking you for values, storing that data at home, or you could ask some provider to actually gather the data for you. And if we do that, just a brief into the actual calls. It's a bit bad picture, but you see the arrows anyhow. So you're a client, you need the data, you send the request. The XML spec would see something like in the left corner there. Oh. Presenting wrong. Fault number 1. You would send a GET from me to a client. I need the momentary values you have. I'm not saying anything of the exact field that I'm looking for. So that would bring me the one that I would have access to. And I would get a reply, accepted. And later on, since this is a very, it's not a synchronous, it's a very asynchronous protocol. Chat can happen in any direction at any time. You will get the message that the temperatures has been read out. The reason for the accepted is that it could take a while for a device to get the data. Perhaps it needs to do equations to calculate the actual CO2 level in the room, because it first needs to calibrate the sensor and do the work and find the data. It could also be the fact that this client is a utility electricity grid, and you asking for the values inside the electricity grid, and you will get 10 million messages back from each electricity meter because you asked the device, which happened to be a utility, for all the values. We'll go back to another knowledge which will, sorry.
If I understand it right, each client can connect, talk with each client if they're friends.
Yes.
But if we take the example, a sensor, a temperature sensor in the middle of Stockholm, open to everyone, and lots of other clients want to read data from this open, is it too much data? I mean, 1 million Stockholm.
Yeah. The question is, would one temperature sensor be friend to the whole of Stockholm, having millions of friends? No. That friend would use the publish subscribe function, which is available as well. Perhaps in XMPP, yeah. There's a publish subscribe extension as well, where you can whitelist and blacklist people to be using that publish subscribe. Or you could be in that multi-user chatting environment where all the temperature sensor or city would talk, and you just listen for the ones you won't like to hear. But in multi-user chat, everybody hears everything that everybody else is talking about. So all data is going back and forth to all clients that are part in the room, which then tend to get better in publish subscribe. You see your provider and then you have the subscribers. So it depends on how many devices you have and who's to control what. If you go for the presence and the friendship, or you go for a publish subscribe. So if you're a small temperature sensor, which then would bring the data quite quickly, you would skip that accept and throw the messages directly. So you get a request and response scheme instead. And if you have many values, you will in the end say, I'm done. So you have a request response, and since it's TCP/IP over TLS over machines, it's very predictable that you really get the messages. There is also a function in several servers that you could turn on if you want to, which is message buffering. If you get offline and got online again, you will get the messages that you have. You see that in Skype, for example, when you have been offline and you turn on the machine and it's dying for all the messages that's coming down. So then you have the control. The reason for making two extensions for it is that usually you have a lot of sensors that are just readable. So they don't need to implement the other part. So when you're asking for discovery, you can find all the ones that just have sensor values. And then you could get the information, well, you have a control part as well. Control could of course be configuration parameters as well. And control looks more or less the same. It's a request and response. I do a set. I throw in a Boolean value called an output to value true. Then you have an XML definition of how Boolean should look like. So we have extensions for long, strings, time, so it gets a very defined world. And then you will get the response, yeah, that was nice. Or I couldn't reach it, or there's a problem with it, and so on. So then it's a very problem of who to befriend to who. So I'm not friend with anybody. I'm a temperature sensor. I'm bought from any company. I have a preset connection to a server, a provider, so I would connect. And there's a hash code on me, which is unique, which is my ID on the network. So the first friend I would get would probably be the one having the hash key. So that's my first friend, the best friend I have. Next time I get a friend request, I need to ask that best friend, really, am I allowed to be friend with this guy over here? So you have more or less an LDAP server, perhaps, if that's my best friend, or your mobile phone. So I would just send, am I allowed to be friend with this one? Then you're the provisioning server in your phone. Instead of having an API somewhere on an HTTP page where I'm allowed to create those relations in that domain, I am now able to control any of my devices in any domain if they adhere to that provisioning function. So I would be the best friend of my heat pump and the best friend of my alarm, even if it's a very short alarm. I can then let them be partners. And I could also, in the next question, when the heat pump asks the very short alarm about the status, if it's alarmed or not, and my alarm asked me, should the heat pump really read the status of my alarm? And I can say no. Then you have the authorization of actual values, which is the provisioning extensions. So you can implement the provisioning yourself or at the server end. So if you're a provider of devices, you could do the provisioning, taking care of the heat pumps and everything, and then you could let the customer be able to have the actual friendship of his devices and what to do. And you could take care of having a ready-made heat service or changing the compressor in the heat pump when it's bad. So you just sell the service of heat instead of selling the heat pump. So we talked a bit of the utility network. How many have seen some of those protocols? There are a lot of them. And if you do some Google searching, I bet you find an IP gateway for each of them. And if you go for the industrial one, Profibus and Metasys and so on, you would find several IP gateways. So that's where we're aiming. That gateway should be connected to the network. Not only TCP/IP, because then you're transporting Modbus over TCP/IP to another Modbus thing, which is just dumb. Modbus is a protocol where you ask for a byte, and you get a byte. Then you need to read the installing instructions to find, oh, a byte. That's a temperature. I need to divide it by 10 because it's just an integer. And it's spanning between 0 and 256. In XML, you can ask for that information, and you would instantly know it. So therefore, we need something called a concentrator. Because I asked that IP gateway to get the values. Okay, I get 10,000 values back. It's temperatures around the factory. Perhaps I need to ask that thing, well, how do you look like then? Yeah, I have a tree of devices. I have the operating floor, the next floor, the paper mill machine. So I create a tree of devices that you can ask me to get. And the actual field you asked for earlier is the temperature at the cellar. So then I have exposed a way of graphing the devices that is behind the gateway in a common way. So regardless if it's Zigbee network or it's the KNX network, you can make it look like the same thing. So you can always introspect another network, which will, of course, is a very need for those integration projects. Otherwise, you're back again to looking at the API, understanding how it works, and waiting for that fantastic protocol that will do the combination of everything. But now we found it. And I don't think we should go into any more of the exact differences. So the idea, if we go back to that, it's how do you bridge the domain silos? Lower the threshold of API integration. Getting one company to talk to the other company without doing integration and without needing a man in the middle. Because companies and business model don't really work with the man in the middle. And there's a big organization in the US that likes the man in the middle as well. So if you could not use the man in the middle, you can enforce any encryption you would like. You could actually encrypt every XML package in the device and have a key in the other device. Then the network won't know what you're transporting, if you would like to go that way. Going back, we've talked about it's XML. Okay, so you need a bit of computational power to create that. The Arduino, we need TLS as well. There's a V2C standard called EXI that is compressing XML in a very defined manner. If you now have this XML schema, we see that, well, we have 4, 5 different tags, quite talkish, but just 5. So we need 3 bits to distinguish them. So if you take away all that and use binary bits for the tags, then you have a lot of text. This timestamp is different, this programmable. If we have text, we could just do a hash table of the texts and replace them. And then we have a schema, so we know when which piece will be coming. So we don't need the exclamation marks and everything. That could also go. So the final thing that would change, talking to a temperature, would probably be a little value somewhere. The rest would be a binary thing. Then you could create in memory a binary packet that you would be transporting. Instead of doing a string of XML in a DOM parser or whatever, putting in the value, then compressing it, and then throwing it on a line. The V2 standard gives you a C code generator for C stubs to create those binary parts. So it's a very defined way of going to a binary XML, which is very promising for small devices. Then you can have more or less, I mean, you don't change the schema for a temperature sensor so often. But it also is extensible still, because when the server packs this up, he could look on a schema definition and say, oh, it's this. So he could extract it, regardless of what it was from the beginning. So any questions about that? Yeah, I can repeat the question.
I understand how you define the extensions for this application, and I understand why you want to build it this way. I'm interested in knowing why you think XMPP is more appropriate as a protocol than, say, SIC, or anything else you would have.
What's the protocol?
For example, ZIP.
ZIP?
CIS is a very similar protocol, and it's a lot older. So I'm just wondering, what is the specific advantage of XMPP compared to other protocols?
I haven't looked at ZIP. I know they use ZIP in XMPP as well for starting video signaling somewhere. So they get the ZIP information over XMPP to start a video conference in some way. They call it Jingle. The main thing I see when I started this project was to get companies understanding what they should do. And when I'm talking about chatting, they sort of grasp it quite instantly. They see that, well, it's just me and you talking, and leverage that to devices. So I get past the first level of doing things, so I could get to the technicians. I think that's the main thing, and it's working very much. I know SIP is doing a lot with that's a phone.
SIP is UDP, which is normally filtered in firewalls, so it won't work. So.
Oh.
But there is a SIP version of SIP. Okay.
Yeah. And it is point-to-point, just like it used to initiate the sessions. Just basically like XMPP.
Okay. And if you were to transport, where do you define the transport data, such as, is it a SIP communication community somewhere defining how it should look like?
Well, there is a standard, and that's what is used mostly for IP telephony, for example. So if you have an internet service provider that gives you free calls to landlines, they use SIP.
Yeah.
It's quite similar. I don't know the details of the protocols, but I think they are quite similar. And
Yeah, could be possible. I don't see, this is yet another way of doing it. And it's not the final solution, I would say. We've started it 2 years ago. It's the snowball. I hope it will roll down the hill and be big.
Google Talk selected XMPP, so perhaps there is a reason.
They use it, yes. Well, Google Talk is still working, but the Google Hangouts, when they do all the videoing and all the voice transporting and everything, they wanted to have higher control of what they are doing. So you can't go from a Hangout to the Google and to the XMPP network. But if you just do Google Talk to do chat, they do federate it still. But that's just because the standards of the XMPP and the video conferencing has not been following as quick as what's happening with Skype and all the other video conferencing thing. So, does it work then? Well, this is up on the balcony. And I have a few friends on my friend list. These are ordinary friends, humans, which I've been chatting to. Oh, sorry, wrong window. Where is Jabberwocky? There it is. These are a few of my other friends. They're more or less machines. And there's a few called the Beatles. They are actually lamps. So if I were to talk to John and say hi to him, he would answer me a nice thing. I'm an IP address, I'm a resource. So if I ask him to toggle, he would of course do that. Bit of a bad language, but it works. I could have perhaps asked him to have a hue of 10,000. And the color is very hard to see in that camera. We could go for a hue of 65,000. Perhaps it's nicer to just have a 5 seconds transition. It's hard to see, but it's slightly red. Yeah, but there's a demo up there that's doing the brightness constantly. So it takes me, because that's the Yoko. She's controlling John. She's wife. So there's a light sensor up there, so when that's dark it gets strong lights. But we could go for the Beatles instead. And we can ask the Beatles to toggle. Then both lamps, you see the one in the background? Because they're part of the group called Beatles. So I'm sending messages to different views, which would be more or less personalities. So a device could go in and have different personalities, depending on them, who you are friend with. So a heat pump could be have a public part where it shows the outside temperature, and the private part is just the compressor and so on. That's up to you to model. You can choose any way you would like. And of course now we're using the chat transport layer. We just have a language, T for toggle, and I have done the both coding, so that would be working. And saying hue equals, that's my coding, so that's my API. There is the place where the XML comes in. If I were to use XML, it's defined by the XMPP.org how it looks like, and we would transport the same data. So I have a little script here, throwing XML. And it's throwing XML towards a little relay in a house in my office, turning the relay off every 6 seconds. And if I stop the script, it will stop blinking. So that's Python code. There's a few lines of code. Starts up a session. There is clients in every language, so doing a Lua client or whatever is very easy. I have 10 minutes left. Well, I think we should go for the 10 minutes for discussions then.
How much is defined in this standard? Can you define different type of sensors, for example? Or,
in the 5 that we have defined at the moment, they are on the XMPP site, and they just go for the physical transport. And we are now working with the extension called interoperability, which will then add to these and saying, I'm a refrigerator. So if you're a refrigerator, what do you have? Well, the common denominator of the refrigerators would be a door switch, a temperature sensor, and perhaps the status of the compressor. That's common for all refrigerators. And then any company could add, of course, optional fields if they want to. So there's the notion of interfaces, which is the one that Zigbee has defined in their smart energy. And that's the tricky part then, to really get them to do the same thing. For heat pumps, for example, some doesn't provide a temperature control of the actual temperature through the radiators. They have some curve that you need to create. And that's, I would think, would be very sinus-formed way of getting things interoperable. If it's an incentive for free devices to look alike, wall sockets, why can't wall sockets just do the same thing? So there's an interoperable part. We are using a GitHub. You can search for Joachim Lindborg at GitHub. That's the Python package, which is it's available for anybody to use. We are doing a Java implementation and a JavaScript implementation in the project. But the latest version of all extensions are in this IoT catalog. So we're working on eventing, which is very interesting, when you need those events to throw off and be published on Subscribe. And also the concentrator, and we are also thinking down to battery-powered devices, because battery-powered devices doesn't like a presence information from all the clients. It would lose the battery quite quickly. So you need to throttle perhaps data at the server end. But as soon as you change things on the server side, it gets more complicated. Then we are sort of into the XMPP core parts more. And it takes longer time to get the implementations out to servers than clients. And well, that's more or less that. Any more questions? We're working on a few tutorials. I've done a few meetups. And if anybody interested, we could go for a trial somewhere and start up at your company or whatever. And to contact me, I would say you go to sust.se.
What are your thinkings about virtual devices like a house, for instance? I mean, if you model the world for a replicator, it should contain what a normal house perhaps could contain.
Yeah, could be. And
Device, it's a logical thing you can sell as a service, software as a service.
yeah, and you could do the concentrate extension and provide a knowledge of rooms with sensor in them and sort of a tree of your house. So you actually would go down in the tree to look, well, I need a temperature in the upper floor or down floor, or to create a nice graphical interface. Or just flat file of all the values. It's more or less up to you to model what you would like to do. So if you go for the project Open Hub, for example, it's an open source project called Open Hub, where they integrated Zigbee, Z-Wave, a few serial port protocols. That would be one thing you could have in your house. Or if you're into MQTT, you could let a Raspberry at home be an MQTT machine throwing all the data around in your house, so you get the wall sockets and everything working. And then add an XMPP client and publish the fields that you would like to have. Vacation mode. It would shut down the house and go for some schema. Instead of having Philips Hue lamps as IDs. So every lamp would be a friend of you, and you have hundreds of things at home, and you need to have friendship relations and do the logic. It's take you a while. You probably would lower that. But if you're into if then that or links, and would like to do the logic somewhere else, well, it's up to you.
Then we can model the neighborhood, for instance, and connect our homes together.
Yeah, and you can share if you're back home or away, and when the sports vacation everyone goes away, you don't need to turn the street lights on. Perfect energy efficiency. Perhaps the burglar likes it, but... And if the neighbor door's alarm goes off, you perhaps could alert all the ones in the other. You can turn their sirens on in the whole neighborhood. And, well, it is a way of thinking, a bit different than usual cloud silo database thing. Of course, there's more tricky things around the management of all these people, peer-to-peer. And if you even leverage to having certificates at each end, do you have a certificate authority that could create all these certificates? Who to manage when you have a service that goes between businesses and the temperature sensor you're controlling your house with is the oven temperature? Who's to blame? The alarm company that has a sensor for your stove, or you that had created the connection, or the heat company that's draining your money due to the fact that, well, perhaps it gets quite cold. But so that's the where we're working in the project. How does this business model around this work like? It's easier when you have somebody that's an integrator that you pay to do the integration thing, and a service provider that comes with a heat pump and does everything for you. That's why we're using Venova. That was quick, sorry. And we're up on the balcony if you would like to talk more. And sust.se. The project is situated on EEA. EEA SUST.se. Thank you.
Thank you very much.
Thank you.